Hi. In this video, we are going to look at practice problems for binomial theorem chapter. We have already covered the theory, and I'll show you some practice problems so that you can understand the concepts better. So let's begin. Question number 1 says, if the sum of odd terms and the sum of even terms in the expansion of x plus a to the power n is p and q respectively. We have to find out the value of 4pq. Find 4pq. Right. So we have to say sum of odd terms is p. So p should be equal to term 1 plus term 3 plus term 5 and so on. And q should be equal to the sum of even terms, t2 plus t4 plus t6 and so on. Right. So what we will do is we know that p plus q together is x plus a to the power n, right? And what we can do from here is we can write it as p plus q whole square is x plus a to the power 2n, right? And similarly, p minus q will be t1 minus t2 plus t3 minus t4 and so on. So that is obviously x minus a to the power n. Think about it. When you put, instead of plus a, you put minus a, you will get terms like this, t1 minus t2 plus t3 minus t4 and so on, right? So p minus q is simply x minus a to the power n, and therefore p minus q whole square will be x minus a to the power 2n, right? And therefore, if I wanted to find out 4pq, I have to take the difference of these two. So p plus q whole square minus p minus q whole square is equal to 4pq. So therefore, it will be x plus a to the power 2n minus x minus a to the power 2n. That is equal to 4pq. So a very simple problem where we look at the binomial theorem and reverse the sign of one of the terms, and we then collect the terms together, right? Okay, let's look at the second problem. This question says, if t0, t1 till tn represent the terms in x plus a to the power n, then find the expression for t0 minus t2 plus t4 minus t6 and so on whole square plus t1 minus t3 plus t5 minus t7 and so on whole square. What is that going to be in terms of x's, right? Okay, so let's think about it. Now, we know that x plus a to the power n is equal to t0 plus t1 plus t2 till tn, right? Basically, here, if you think about what these terms will look like, these terms will be like nc0 x power n, that is your t0, nc1 x power n minus 1a, that is your t1, nc2 x power n minus 2a square is your t2 and so on, right? So I want to collect all the even terms, but I want them to come with alternating sign, right? So what can we do to get that? So let's replace xa with ia. So what I'm doing is this. So notice what will happen to t0. So there is no term, t0 remains t0 even after replacement. But this term will become nc1 x power n minus 1 ia. So basically this is equal to I times t1, right? T2 will remain, T2 will become I square T2, which will be minus T2, right? Similarly, I cube will be minus I, so it will be minus I T3 next, right? So what we are getting here is when I replace A with IA, I'm getting the terms like this: T0 plus I T1 minus T2 minus I T3 and so on, after replacing I everywhere with A, right? So this can be collected like this. This can become T0 minus T2 plus T4 and so on, one bracket, plus I times T1 minus T3 plus T5 and so on. This is the second bracket, right? Now, we have found out that x plus IA to the power n is becoming equal to this. Now notice that this right hand side is a complex number, and the modulus of that complex number would be root over T0 minus T2 plus T4 whole square plus T1 minus T3 plus T5 whole square. The modulus of the complex number on the right hand side is equal to this. We need the square of the modulus. So basically we need the square of the modulus of this complex number, right? So if you think about that, what is the modulus of this complex number? It is x square plus a square to the power n, right? So when you square this modulus, what will happen is you will get x square plus a square to the power n. That is your answer. X square plus a square to the power n will become your answer for this expression. How are we doing it? We replaced a with IA, and that basically gave us the pattern where terms are alternating in sign, but they are two spaces apart. So T0 minus T2 plus T4 minus T6 and so on. So remember this technique. This is pretty useful in problems. Let's look at the next question. This question says, find the coefficient of x power 5 in the expansion of 1 plus x power 21 plus 1 plus x power 22 and so on till 1 plus x power 30. Find the coefficient of x power 5 here. Now, you could do it one way by trying to find coefficient of x power 5 in each of the terms and then adding it. But then you will have a sequence of combinatorial coefficients, right? What I would say is instead you should first simplify this expression and notice that this is a GP with first term as 1 plus x to the power 21 and common ratio as 1 plus x. So the sum of this GP will simply be first term A is taken common, r power n minus 1. So how many terms are there? There are, if you subtract 20, you get 1 to 20. There are 20 terms here. There are 10 terms here, basically. If you subtract 20, you get 1 to 10. So there are 10 terms here. This is 1 plus x to the power 10 minus 1 by r minus 1. So 1 plus x minus 1. So this becomes basically 1 plus x to the power 31 minus 1 plus x to the power 21. Whole thing is divided by x, right? So this is my sequence. Now we need the coefficient of x power 5 here. Coefficient of x power 5 in this expression. So basically, because it is divided by x, we should find coefficient of x power 6 in the numerator only, right? Because then we'll divide it by x and we'll get the coefficient of x power 5. So we need coefficient of x power 6 in this numerator, and that is obvious. That is going to be 31c6 minus 21c6. So that becomes your answer. So whenever you have a situation like this, where there is a series of binomial expansions and you want to find the coefficient, the method that you should use is first sum the series and then try to find the coefficient rather than finding individual coefficients and trying to add them, right? Okay, let's move on to the next problem, question number 4. It says, find the coefficient of x power 5 in the expansion in the expansion of x square minus x minus 2 whole to the power 5, right? So what we will do here is we'll factorize this first. So if you factorize it, you will realize that this is simply x minus 2 into x plus 1, and you are doing it whole to the power 5. So you basically have x minus 2 power 5 and x plus 1 power 5, right? And now what we have to do is figure out the coefficient of x power 5 here, right? So let's think about it. Both of these expansions will have x power 5 terms. So you will get something like this: x power 5 minus 5c1 x power 4 into 2 plus 5c2 x cube into 2 square minus 5c3 x square into 2 cube plus 5c4 x into 2 power 4 and minus 5c5 2 power 5. That is the first sequence. And the second sequence is simple. It is x power 5 plus 5c1 x power 4 plus 5c2 x cube plus 5c3 x square plus 5c4 x plus 5c5, right? So how will we construct x power 5 powers here? So let's start with this term. This term can multiply with this and you get a 1 here because 5c5 is 1. Then this term, right, this term can multiply with the x term here. So you'll get minus 2 times 5c1 times 5c4 here. There is no other way in which you can get an x power 5 using this term. So that's it. Then you have 2 square 5c2. This is x cubed, so you have to multiply it with 5c3 here. So this and this combine to give an x power 5. Then you have a minus 5c3 2 cube multiplied with 5c2. Again, same pattern, plus 5c4 2 power 4 multiplied with 5c1. And finally, a minus 5c5 2 power 5 multiplied with 1, right? So basically, you have to evaluate the value of all of this. So this is 1 minus 2 into 5 into 5 plus 4 into 5c2 is 10. So 10 into 10 minus 10 into 8 into 10 plus 5 into 16 into 5 minus 32, right? So you are getting basically 1. This is 25 minus 50 plus 400 minus 800 plus 80 into 5, 400 minus 32, right? So this and this and this get cancelled and you have 1 minus 82. So this is minus 81. And that becomes our answer for this particular problem. Minus 81 becomes the coefficient of x power 5 in this expansion, right? Okay, let's move on to the next problem. Question number 5. Here you have to find the number of irrational terms in the expansion of fifth root of 3 plus third root of 7 to the power 36, right? So basically we have this series 3 power 1 by 5 plus 7 power 1 by 3 and whole raised to 36. And we have to find the number of irrational terms, right? So let's write a general term of this series. TR plus 1 would be 36CR 3 power 1 by 5 to the power 36 minus R multiplied by 7 power 1 by 3 to the power R, right? So basically you are getting 36CR 3 power 36 minus R by 5 multiplied by 7 power R by 3. Now we have to find the number of irrational terms, but it will be easier to check when are the terms rational. When will the terms become rational, right? So what are the possible values of R for which it becomes rational? So first of all, R should be a multiple of 3, then only the 7 powers will give us a rational number. So if you take all the multiples of 3 from 3 to 36, we'll be able to figure out when is this first term becoming rational. So for example, when you have R is equal to 3, you'll get 33 by 5. That doesn't work. But R is equal to 6 definitely works. You have 30 by 5, which is 6. Then 9 doesn't work. 12 doesn't work. 15 doesn't work. Then 18 doesn't work. 21 does work. Because say 36 minus 21 becomes 15 by 5. 24 doesn't work. 27 doesn't work. 30 doesn't work. 33 doesn't work. And 36 will work, right? So 6, 21, and 36 will work. These are the three terms that are coming as rational, and therefore the whole series has 37 terms. So therefore, if 37 terms are there and 3 are rational, the answer is 34 irrational terms, right? So we come up to the conclusion for this problem. Okay, the next problem talks about if A1, A2, A3, A4 are the coefficients of second, third, fourth, fifth terms of 1 plus x power n, then we have to find whether the terms a1 by a1 plus a2, a2 by a2 plus a3, a3 by a3 plus a4 are in. The options are AP, GP, HP, and AGP. We have to figure out whether these are in a particular kind of a sequence or not, right? So the terms are pretty obvious. Coefficients of second term coefficient would be A1 is the coefficient of the second term. So that is equal to NC1. A2 is coefficient of third term. So that is equal to NC2. A3 is NC3 and A4 is NC4. These are the fifth terms and the fourth terms respectively. So once we have that, what is A1 by A1 plus A2? That is basically NC1 by NC1 plus NC2. So if you simplify this a little bit, this is N by N plus N into N minus 1 by 2. And if you simplify this, you will end up with 2 by N plus 1. So you should do the simplification yourself. You will be able to prove that this is 2 by N plus 1. Similarly, A2 by A2 plus A3 will become NC2 by NC2 plus NC3, and that simplifies as 3 by N plus 1. And A3 by A3 plus A4 will similarly simplify as 4 by N plus 1. So notice that the terms are 2 by N plus 1, 3 by N plus 1, and 4 by N plus 1. And it is obvious just by looking at it, they have common denominator and they are increasing by 1 by N plus 1 each time. So it is in AP. So we have found that this is in AP. Okay, let's move on. The next question says, right, question number 7. We have to find the remainder. Find the remainder when 32 power 32 power 32 is divided by 7. To find the remainder when 7 is dividing this number. So let's try to approach this problem by using powers of 2, because 32 is 2 power 5. So we can say 32 is 2 power 5. Therefore, 32 power 32 will be 2 power 5 power 32, which will be 2 power 160, right? Now, we have to understand this 2 power 160. So this is going to be divided by 7 eventually. So you have to think about what we'll do there. So, right. So 2 power 160 is 3 minus 1 to the power 160. And I can expand this as a binomial and I will get 160 C0 3 power 160 minus 160 C1 3 power 159 plus 160 C2 3 power 158 and so on till you get a term 160 C 159 into 3 and then you get a 160 C plus 1, right? So notice that all of these numbers are divisible by 3. So you have a number of the form 3m plus 1. What I'm saying right now is that 32 by to the power 32 is congruent to 1 mod 3, or it leaves a remainder 1 when divided by 3, because all of these first terms are divisible by 3 till here. Every term is divisible by 3, only last term is not divisible and it gives a remainder 1, right? So now that we know this, let's try to think about what is 32 to the power 32 to the power 32. So we know that this number is of the form 3m plus 1. So we can write it as 3m plus 1 to the power 32, right? So now, if it is 3m plus 1 to the power 32, actually, it is better if we don't do it like this. So what I will do is, on the next screen, so I have 32 to the power 32 to the power 32. And I know 32 to the power 32 is of the form of 3m plus 1, right? So what I'll focus on here is not on the lower two 32s. I'll focus on this number and I'll say it is 32 to the power something of the form 3m plus 1. And now I'll write this again as 2 power 5 to the power 3m plus 1. And therefore I get something like 2 power 15m plus 5, right? So 2 power 15m plus 5 is coming, and from here I can take a 2 power 15m plus 3 into 2 power 2. So this is becoming 4 into 2 power 3 common 5m plus 1. So this is becoming 4 into, why am I taking 2 power 3 like this? Because that will make it 8 power 5m plus 1. Why do I need 8? Because I want to check divisibility by 7, right? So now I can write this as 4 into 7 plus 1 to the power 5m plus 1. So therefore it will become 4 into 5m plus 1 C0 7 power 5m plus 1 plus 5m plus 1 C1 7 power 5m, and so on. You'll keep getting terms till 5m plus 1 C5m into 7, and plus you'll get a final term of 1, right? So notice that all of these terms are divisible by 7, and therefore the only remainder will be here 1, but it is multiplied by 4. So overall you'll get 4 mod 7. So our number 32 to the power 32 to the power 32 leaves a remainder of 4 when divided by 7. We did the problem in 2 steps. First, we figured out that 32 to the power 32 can be written down like this as a number that leaves remainder 1 when divided by 3. And after that, we worked on it again and did it modulo 7, right? So we converted 2 power 5, 2 power 3 into 8 and wrote 8 as 7 plus 1. So that was the main trick here. I hope you understood. The remainder here is 4, right? Let's move on to the next problem, question number 8. The sum I goes from 0 to n, 10ci multiplied by 20cm minus I is maximum we have to find out, we have to find is maximum when M is the, basically we have to find when is the sum going to be maximum, and we have to find the sum of the digits of M, sum of the digits of M when this sum takes its maximum value. So we'll understand what has to be done when we try to approach this problem and see what is coming here. So let's write a few terms here to get a sense. This is 10C0, 20C M plus 10C1, 20C M minus 1 plus 10C2, 20C M minus 2, and so on till 10cm and 20c0, right? That is the last term that you are getting, correct? Now, how will we get this? So think about it. This is the product of two different series. You can take the series 1 plus x to the power 10, and that will give you terms like 10c0 plus 10c1x plus 10c2 x squared. There will be a term 10cm x power m, and then there will be a term 10c 10 x power 10, right? And you could also take a series 1 plus x power 30, because notice that the 1 plus x power 20 actually, because the second series has power 20 here. So if you take 1 plus x power 20, or rather x plus 1 power 20, you would get 20c0 x power 20 plus 20c1 x power 19, and so on. There will be a term 20cm x power 20 minus m, and after that there will be terms till 20c0 x power 0, right? So if I multiply these two series and I combine this term 10c0 with this term, I'm getting x power 20 minus m. The next term would be 20 minus m minus 1 with this. So again x power 20 minus m, right? So instead of doing this, I should not reverse the series, I think. I should just write the second series as 1 plus x power 20. I want to combine the coefficients and multiply them and get a common thing. So I will do 1 plus x power 20 here, and this will be 20c0 plus 20c1x and so on till 20cm x power m, and this goes on till 20c20 x power 20, right? Now if I multiply the terms, when I multiply this term with this term, I am getting 10c0 20cm x power m. Then I multiply this term with the next term, right? With the previous term rather, not the next term. This is 20cm minus 1. So the previous term here would have been, it would have been 10c1x into 20cm minus 1 x power m minus 1. So notice that this also combines to give x power m only, right? So we are getting x power m here also, x power m here also. And you will see that the first term here 20c0 multiplied by the last term here is also giving us x power m. So when we multiply these two series, what we are searching for is coefficient of x power m in the product of 1 plus x power 10 times 1 plus x power 20, right? So that is 1 plus x power 30, and we need the coefficient of x power m there. So that is obviously 30 cm. So the sum of this series is 30 cm, and now we have to think about when is this going to be maximum. So 30 cm will be maximum when m is the middle term, m should be 15. That is when 30 cm becomes maximum. And the sum of digits of m in that case is 1 plus 5 equals 6. So our answer is 6. The sum of digits of m should be 6 so that this series is maximized, right? Okay, so that's the solution for this one. The next question goes like this. If f of x is equal to summation r goes from 1 to n r squared times ncr minus ncr minus 1 plus 2r plus 1 times ncr. Okay, and we also have f of 30 is equal to 30 into 2 to the power n, right? Technically, I think this should be function of n, because when I do the summation, it will become a function of n. So the question has been stated incorrectly. This is f of n is equal to this. And they have given value of f of 30. They are asking us for the right. The question is not stated very well, but we will try to do the summation anyway. Let's try to do this summation. After that, we'll think about what the data is saying, right? So how do I do this summation? Let's think about that for now. So notice that there is a NCR here and NCR here. So I can group them together, r square plus 2r plus 1 NCR minus r square NCR minus 1. This is what we have. So this is clearly r plus 1 whole square, r plus 1 whole square NCR minus r square NCR minus 1, right? Now we have to do the summation from r goes from 1 to n, right? So, right. So let's think about this. This looks like a telescoping series. If you write some terms, let's see what comes. When r is 1, you get 2 square nc1 minus 1 square nc0. The second term will be when r is 2, it will be 3 square nc2 minus 2 square nc1. And the third term would similarly be 4 square nc3 minus 3 square nc2, and so on. So notice that this term is getting cancelled here, this term is getting cancelled here. So basically you'll end up with n plus 1 whole square ncr ncn minus 1 square nc0. The last term of the first bracket and the first term of the last bracket. So that is what will end up happening. And you are ending up with simply n plus 1 whole square minus 1. So you are getting n square plus 2n, right? So f of n is simply n square plus 2n. Now f of 30 becomes 30 square plus 2 into 30. And we have to find out the value of n from here. So if f of 30 is 30 into 2 power n, which is equal to 30 square plus 60, we have to find what is the value of n basically. So this is equal to 960. And if you divide 30 and 960, you'll get 32. And therefore n is equal to 5. So the question was asking us to find the summation here and then using this data, find the value of n. The summation is easy. You don't have to use any properties of binomial theorem in this summation because we got it by simple telescoping series. Once we did telescoping series, we were easily able to find f of n, right? Let's move on to the next problem. This question says, if f of x is periodic with period t such that f of 2x plus 3 plus f of 2x plus 7 is equal to 2, then we have to find the coefficient of m to the power minus 3t in the expansion of m plus b by m cube to the power 40. So basically the question is here, the binomial theorem part is here. We just have to do a function theory or function problem here. We have to find the period of the function when f of 2x plus 3 plus f of 2x plus 7 is equal to 2, right? So that is the first part of the problem. Find the period here. Okay, so let's think about it here. F of 2x plus 3 plus f of 2x plus 7 is always equal to 2. So if I put if I put u is equal to 2x plus 3 or y is equal to 2x plus 3, I'm getting f of y plus f of y plus 4 is equal to 2, right? And instead of y, if I put y minus 4, I will get y minus 4 plus f of y is equal to 2 as well, right? And now what I will do is I will subtract these relations. If I subtract these relations, I'm getting f of y plus 4 minus f of y minus 4 is 0. So I'm getting f of y plus 4 is equal to f of y minus 4, right? So we are getting that f of y will be equal to f of y plus 8, right? So we are getting that f of y has period 8, right? Now y was equal to 2x plus 3. So f of 2x plus 3 has period 8. So obviously f of x has period 8 by 2, which is 4. So the period of f of x would be 4. How? We just replaced it with 2x plus 3. We got this value. From here we got this. And we got that f of y has a period of 8. But y was 2x plus 3. So from properties of periodic functions, when y is 2x plus 3, f of x will have period of 8 by 2, the coefficient of x, right? So period of f of x is 4, so therefore t is 4. And now the problem is find the coefficient of x to the power minus m to the power minus 3t or m to the power minus 12 in the expansion of m plus b by m cube to the power 4t, so 16, right? So write the general term here. The tr plus 1 term will be 16cr m to the power 16 minus r b to the power r by m to the power 3r, right? So this becomes 16cr m to the power 16 minus 4r into b to the power r. And we have to make 16 minus 4r should be equal to minus 12. So 28 should be 4r and r should be 7. And in that case, our coefficient will become 16c7 b to the power 7. This is the required coefficient that we need, right? So solve the periodic function part of the problem, get t is equal to 4, and after that the problem is done. Okay, so let's move on to the next one. This was question 10. So the next problem is question 11. And it says, find the coefficient of x to the power 2016 in the expansion 1 plus x square plus x cube plus x power 4 to the power 1001 multiplied by 1 minus x to the power 1002 and multiplied by 1 plus 7 x power 14, right? We have to find coefficient of x to the power 2016 in this series, right? So again, first what we will do is simplify this stuff, okay? So this is a simple GP. You can see the sum of this GP will be 1 minus x power 5 by 1 minus x, right? And this power is 1001 and we have 1 minus x to the power 1002 here and 1 plus 7 x power 14 here. So we are getting 1 minus x power 5 to the power 1001 multiplied by this is 1 minus x power minus 1001. So it becomes 1 minus x power 1 and 1 plus 7 x power 14, right? Okay. Now we can multiply these two terms and we'll get 1 plus 7x power 14 minus x minus 7x power 15. And we have 1 minus x power 5 to the power 1001 here, right? So what is the general term of our series here? The general term of our series here is 1001 CR 1 to the power 1001 minus r and minus of x power 5 to the power r, right? So we are getting 1001 CR minus 1 to the power r x power 5r from here, and r goes from 0 to 1001, right? And outside this sum, we have this polynomial. This is multiplied by 1 plus 7x power 14 minus x minus 7x power 15, right? So now from this series, we are supposed to find the coefficient of x power 2016. So let's think about that for a moment. How do we get terms of x power 2016 from here, right? Okay. So can we get a 2016 power directly here? Because then we can multiply it with 1 and we'll get the answer. But we can't because this is only going to have powers of 5r. So 2016 is not divisible by 5r, right? So that is not possible for us. So looking at this term, we need x power 2016 minus 14, so 2002. That is also not possible here. So these two terms multiply and don't give x bar 2016, right? Now minus x is here. That means 2015 is possible here. So r will be 403. If r is 403, you'll get 2015 here. So you'll get 1001 c 403 minus 1 to the power 403, and whole thing is multiplied by, this is the power 400 power 2015 from here. Whole thing is multiplied by minus 1, right? Minus 1 power 404. So you're getting 1001 c 403. That definitely will have power of 2016. Then again 15, if you subtract 15 from here, you get 2001, which is not possible from here. So this is going to be the only term that gives us x bar 2016. And that becomes our answer, right? I hope you are understanding what we did here. We are expanding this series as a GP sum and then getting one binomial term, and the remaining terms we are combining together in a separate polynomial. And then we are multiplying the terms to figure out which terms are coming. Let's look at the next problem. Coefficient of x to the power 6 in 1 plus x, 1 plus x square square, 1 plus x cube cube, and so on till 1 plus x bar n to the power n, right? This is the problem. And we have to find coefficient of x bar 6 in this, right? So let's think about it. So we have 1 plus x here, 1 plus x here, and this will give us terms which are like this: 1 plus x bar 4 plus 2x square. And this will give us terms like this: 1 plus 3c1, it is power 3, so 3c1, so 3x cube, 3c2, so 3x power 6 plus x power 9, right? After that, we'll have 1 plus x power 4 to the power 4, the expansion of which is 1 plus x power 4, 4x power 4, plus 4c2, 6x power 8, and so on, right? So that is also valid because you have x power 4 here. So basically, we have to look till the x power 5 term and the x power 6 term, I think, right? Okay, so let's focus our attention here. We have 1 plus x, one plus 2x square plus x power 4, 1 plus 3x cube plus 3x power 6, plus we'll ignore this term. We'll ignore this term because we cannot use x power 9 to get a coefficient of x power 6. X power 9 is useless because it has higher power than 6, right? So we'll just write this. Here we will write only the first two terms because other terms can be ignored because they have higher powers. And then in the next one, we'll have 1 plus 5 x power 5. That's it. The next one will have 1 plus 6 x power 6. Right? We are ignoring all the higher powers and we are ignoring everything higher than x power 6. Everything higher than the sixth bracket here. Right? And from here, we have to find out how to get coefficient of x power 6 here. Correct? Right. So we can multiply some of these and group some of them together to figure out a better polynomial. So what I can do is multiply these three. We are getting 1 plus Okay, multiply these two first. 1 plus, we'll ignore the term 20 x power 9 because that doesn't matter for us. We're getting 1 plus 5 x power 5 plus 4 x power 4. Multiply this with 1 plus 6 x power 6. So we're getting 1 plus 6 x power 6 plus 5 x power 5 plus 4 x power 4. And we are ignoring the multiplication of these, any 11 powers or 10 powers we are ignoring. We're getting this sequence here. This is the polynomial that can give us x power 6. We are ignoring all the higher powers, right? Similarly here, we will get, here all the multiplications are possible. So you'll get 1 plus 2x square plus x power 4 plus x plus 2x cube plus x power 5. And then we have to multiply it with this. So 1 multiplies with all of them with no issues. So we get this term as it is. 3x cube will only multiply with this. So you'll get a plus 6x power 5 and a plus 3x cube, and x power 4 cannot be done. We get a 3x power 4 and we'll get a 6x power 6. And this can only be done with a plus 1 3x power 6. So basically I'm multiplying this with this and only selecting those powers which are lesser than or equal to 6. So overall this whole expression is this sequence plus this plus this. So we will end up with 1 plus x square is here. There is no other x square. So you get 1 plus 2x square. X cube is here, 2x cube, and 3x cube is here. So you get 5x cube, right? How did I get a 3x cube? 3x cube into 1. Right, right. So you get a 5x cube. So this and this is done. 2x square is done. 1 is done. Then x power 4 is there here and here. So 4x power 4 should come. 4x power 4. So from here and here. And there is an x as well. So, okay, so I should write an x actually. X power 5 is 7x power 5 and 9x power 6. And I have to multiply with this to get terms of x power 6 and all. So 1 can give with a 6, you get 1. So you have a 6 here. 2x square can multiply with 4x power 4. So you get 4 into 2, 8 here. 5x cube cannot multiply with anyone. 4x power 4 cannot multiply with anyone. X can multiply with a 5 here. So you get a 5. And 7x power 5 cannot multiply with anything here. 9x power 6 can multiply with a 9, right? So you get basically 14 plus 9, you get 14 plus 5, 19 plus 9, 28. So coefficient of x power 6 is 28 in this. Now think about what we have done. This is a little annoying and you need to know the technique what we did, right? So we are writing each expression first of all, we are expanding it and collecting all the powers which are less than 6. You can ignore any terms that are higher powers than 6. So when you do that, you end up with terms like this: 1 plus x, this, 1 plus 5x power 5, 1 plus 6x power 6. After that, again, you're repeating the same process. I am multiplying the first 3 and the last 3, and I am only collecting the powers that are less than 6. because those powers can only multiply to give x power 6, right? So if you do that properly, you will get this term when you do for the first three, and this term when you do the last three, collecting only powers less than 6. And after that, I'm simply multiplying and see how to get x power 6 there. So when I multiply with 1, I take with 6 x power 6. So I got a 6 here. When I check with power 2 here, I can check with 4x power 4. So I get 4 into 2, 8 here. 5x cube doesn't multiply with anyone to give x power 6. 4x power 4 doesn't multiply with anyone. X, however, does multiply with this. So you get a 5 there. And similarly, 9x power 6 can multiply with a 1. And that's how you get the coefficient that you need. I hope it is clear now. Okay. The next problem goes like this. Question 13. We have to find the sum of all the coefficients of those terms in the expansion of a plus b plus c plus d to the power n, which contain b but not c. Okay, so we have to find the sum of all the terms which contain b but not c, right? So think about it. How will we get a term that contains b but not c? So first think of this expansion. This is a multinomial series. If you want to write the general expression, it will be something like this: n factorial by n1, n2, n factorial by n1 factorial, n2 factorial, n3 factorial, n4 factorial, a power n1, b power n2, c power n3, d power n4. And this is a summation over all such terms where n1 plus n2 plus n3 plus n4 is n. So all the possibilities are there such that n1 plus n2 plus n3 plus n4 is n. These are the terms that you will get. But we have to find the terms that contain a particular letter but don't contain another one, right? So if you want to find sum of terms containing or not containing C, sum of the coefficients of those terms. So we should put A as 1, B as 1, D as 1, and C as 0 for that. Think about it. If C is 0, then obviously all the terms containing C will vanish. And if A is 1, B is 1, D is 1, the remaining terms will simply be the coefficients, right? So this will be basically 3 to the power n, right? Actually, in the problem, it was a plus b plus c plus d to the power 8. So n was already given. So this was 8 actually. So this is 8. We are getting 3 to the power 8 here, right? N was basically equal to 8, right? This is the sum of the terms containing, not containing C. Now, similar logic, if you follow, sum of terms not containing B and C, not containing B and C. If you try to find that, in order to do that, you would have to put A as 1, D as 1, and B and C both 0. So you will get 2 power 8 there, right? So the terms that don't have both B and C add up to 2 power 8 and the coefficients, and the terms which don't have C add up to 3 power 8. So therefore, subtracting these two, you will get terms with B but not C. And that will be basically sum of the terms will be 3 power 8 minus 2 power 8. So that is becomes our answer. So you have to figure that out, calculate it and figure out that answer, right? So that is our solution for this one. The point is basically that in a multinomial expansion, all you have to do to find the sum of the terms is put A, B, C as 1 and some of them as 0 if necessary, if required, right? If those terms don't have to come. Okay, let's look at the next problem. Question number 14. So this problem says if n is an even integer, or rather this question goes like this: if x is equal to 2 plus root 3 power n and n belongs to natural number and f is equal to the fractional part of x, then find out f squared by 1 minus f, whether it is irrational, odd, even, or a non-integer rational number. So this is a pretty standard question. I'm sure you have seen this type of problem before. What we will do here is try to find out what is this f by using the similar series 2 minus root 3 to the power n. We have x is equal to 2 plus root 3 to the power n, and f is basically x minus gif of x. So we know that x is equal to f plus gif of x, right? So basically we know gif of x plus f is equal to 2 plus root 3 to the power n, right? Now we'll call a new binomial series. Capital F is 2 minus root 3 to the power n, and we know that capital F is between 0 and f and 1 because 2 minus root 3 is less than 1, right? So when I do capital F plus x, capital F plus x, if I do, I am getting 2 plus root 3 to the power n plus 2 minus root 3 to the power n. And you will notice here that all the root 3 powers will get cancelled and you'll get twice of terms like this n, c, 0, 2 power n and so on. So this is coming as an even integer. This is coming as an even integer. Now, if we think about that, it means that f plus small f plus gif of x is equal to even. We are getting this. So that means we can also figure out, this is one condition. We also can do capital F times x. That becomes basically 4 minus 3 to the power n. So that is 1. So we know that x is equal to 1 by f, right? X is equal to 1 by f, we know. So from there we can say that gif of x plus f times 1 by f is equal to 1, right? So x is equal to 1 by f. No, not times 1 by f. We know from here that this is x times f. So we know gf of x plus small f times f is equal to 1. We know gif of x plus small f is equal to 1 by f, right? So now from this condition, we can say that f plus f is equal to some even number minus gif of x. So this is an integer. And if f plus f is an integer, the only integer it can be is 1. Because both are positive, but both are less than 1. So it cannot be equal to 2. So f plus f is equal to 1 is coming from here. And basically what I mean is capital F is 1 minus f now. And if capital F is 1 minus f, we can put it here 1 by 1 minus f here. And we are getting gif of x is equal to 1 by 1 minus f minus f. So 1, this becomes 1 minus f plus f squared, right? 1 minus f plus f squared by 1 minus f, right? That is equal to gif of x. Uh, so I'm getting this equation now. Gif of x is equal to 1 minus f plus f squared by 1 minus f. So basically that is 1 plus f squared by 1 minus f. And we are getting f squared by 1 minus f is equal to gif of x minus 1. So this becomes clearly, this is clearly an integer first of all. So now we just have to figure out whether it is an odd and an even integer, right? Gif of x minus 1. We know that x plus f was even, right? And this was gif of x plus fractional part of x plus f, which was even. And we know that this is 1. So therefore, we know gif of x is odd. So gf of x minus 1 is even. So this basically f squared by 1 minus f is an even number. So the idea in such problems is always add the series with its conjugate binomial series and multiply it also. And notice that if two fractional part numbers are added, then they will be less than or equal to 1. So the only way f plus capital F could be equal to an integer is if it is equal to 1. It cannot be 2 and it cannot be 0 also, right? So that is our solution for this problem. We'll look at one more problem of this kind, and let's do that also to just reinforce the ideas that we have seen. So question number 15, if n is greater than 0 is an odd integer, and x is equal to root 2 plus 1 power n, and f is equal to x minus gif of x, then we have to figure out what is 1 minus f square by f, right? Again, we have to figure out whether it is even, odd, irrational, or what is it, right? So let's think about it one more time and understand this whole concept. So we have x is given as this. So what will be 1 minus f square by f, right? That is what we have to figure out. So let's define our new binomial as capital F is root 2 minus 1 power n, and let's do the multiplication of x and capital F. We'll get 2 minus 1, so 1, right? So this is one result that we have. And if I subtract x minus f, right? So I'm going to do root 2 plus 1 power n minus root 2 minus 1 power n. So think about what will be the terms. This is ncn root 2 power n plus nc n minus 1 or nc0, and this is nc, I'll just write it like this. nc0 here, nc1 root 2 power n minus 1, 1, nc2 root 2 power n minus 2, and so on. And we are subtracting nc0 root 2 power n minus nc1 root 2 power n minus 1, and so on. So notice that upon subtraction, we have to think about whether we want to subtract or whether we want to add. 1 second. So if I subtract, okay, we knew that n was odd integer. So n is equal to 2k plus 1. So that is why subtraction makes more sense, because when it is odd integer, 2k plus 1 minus 1, n minus 1 is even. So this becomes a rational term, rational and rational, because root 2 is raised to an even power here. So when you subtract, these terms get cancelled, these terms get cancelled, and these terms get added. You're getting 2 times nc1 root 2 power n minus 1 and nc3 root 2 power n minus 3. And these are all rational numbers. So we are getting an even number here. So what we have is x minus f is even, right? And we also know that 0 is less than f is less than 1, right? Great. So now let's think about what is the conclusion from there. X minus f is coming as an even integer and x times f is coming as 1, right? So from here we can say that we can write the x as GIF of x plus small f minus capital F is equal to even, right? So, right. If you think about f minus f, both of them are fractional parts, so it will be between minus 1 and 1, right? And we have this is an integer and this is an integer. So f minus f is also an integer. And if f minus f is an integer and it lies between minus 1 and 1, the only possibility is equal to 0. So you are getting f is equal to capital F. Or now we can say, putting that in this equation, we get x times f is equal to 1, right? And this is GIF of x plus f times f is equal to 1. So we are getting GIF of x is equal to 1 by f minus f. So that is 1 minus f square by f, right? So what we get is GIF of x is equal to this. So 1 minus f square by f is clearly equal to an integer. And since f minus f was 0 and this side was even, GIF of x is an even integer. So we have gotten that 1 minus f square by f is an even integer. I hope you follow the logic here. First thing to figure out was that product of x and capital F is this. Second thing was we subtracted the two series, x minus capital F. Here subtraction is better because n is odd, and when you subtract, you end up with x minus f is an even integer. And writing x as gf of x plus small f minus f is even, then because this is an integer and this is an integer, f minus f is an integer. But the value of f minus f can only be between -1 and 1. The reason being that both of them are fractional parts. So that means the only possible integer is 0 and you get f is equal to capital F, right? Once we get that, we can use it here and say x times small f is 1. So gf of x plus f into f is 1 and we get this expression. And that solves our problem. I hope everyone has understood the logic of these types of questions. They are not difficult. They are just there is a standard approach to do them. And you need to know that, right? Okay, let's stop at this point. In the next video, I'll do more problems. So the overall different types of problems of binomial theorem that I want to share with you are not yet done. I'll do some more problems to explain the ideas and we'll continue from this point. If you like the content, please subscribe to the channel and share it with your friends. These videos will definitely help you revise your algebra for JEE Mains. Okay, so that's it for this one. I'll see you next time.